What is a data science project? What are the major milestones of any analysis? What should a data scientist start with and how to execute it from start to finish? It's important to follow an established pattern so you won't find yourself having solved the wrong problem. And you'd be surprised how frequently data scientists oversee the actual goal and waste a bunch of time writing useless code. We will walk through each stage of the cross-industry standard process for data mining, and by the end of this video, you'll know exactly what to do. A data science project is a turnkey solution of an analytical problem based on the provided data. And it's not just some code that runs on your local machine, but a piece of software. But we're jumping ahead. To set the scene, let's assume that the project we're going to be solving is real estate prices prediction for a major bank. The first thing we need to do is understand the business. Why exactly are they estimating real estate prices? This is an important question which will affect all your subsequent steps. Let me give you an example. The bank might intend to invest into real estate, and for this matter they are trying to pick the most promising houses which value is most likely to increase after a certain period of time. In this case, we understand that this is a time series forecasting problem, and we already know what kind of data we're going to need. Statistics of how certain homes value grew over time, preferably a large period of time, maybe 2 years, because as a rule of thumb, your backward-looking statistic has to be at least twice longer than the intended forecasting period. Or the bank might have thousands of mortgage homes in their portfolio, and maybe some of their customers went bankrupt, and now the bank needs to estimate current real estate value of these homes. This is a traditional regression problem with home characteristics as features and their prices as targets. These are two completely different problems to solve. They require different data and different approaches to pre-processing and different modeling techniques. You need to make sure that you understand the final goal precisely. Next, we need to understand the data. In the context of the previous step, you might already have an abstract understanding of the required data. Now you need to confirm that the data your client has is aligned with the task at hand. And this is not a trivial task. In most cases, it's going to be raw data, unstructured, clean, dirty, in different databases, not prepared for machine learning. The first question here would be, are there labels available? For our particular example, real estate homes predictions, the labels would be the statistical homes prices at which they were sold. And this is easy. But if, for example, your task is to predict customer churn, then in 99% cases, churn flag is not going to be included in the data. Instead, it's going to be a database with customer interaction records, with maybe checks and visit records and the services they purchased, and it will be your job as a data scientist to extract those labels. So in this case, you might want to ask the customer, well, what is churn? How do you define it? And the answer would be something along the lines of, well, churn is when the customer didn't buy anything for the past 1 month. And now you already know the rule according to which you can find in statistics those customers and label them as churn examples and others as non-churn examples. This is an interesting topic, by the way, and I have a customer churn explainer video in production. It should appear here somewhere shortly. Okay, we worked out the labels. Now what about the features? Does the customer has characteristics of the event that we're trying to predict? You never know which exact factors will contribute to the model's accuracy. And the beauty of machine learning that a model can pick up the most unexpected predictors and their combinations. But you must at least do a logical assertion of what the customer has. So if we are predicting real estate prices, then you most definitely are going to need homes characteristics, the descriptors of the areas and locations. If your data time frame is extensive, maybe a couple of years, then you might need macroeconomical data corresponding to the dates when those houses were sold. Things like mortgage percent, unemployment rate, maybe inflation. All these factors affect a major investment decision and were impacting the home prices when they were sold. To recap this step, you must have a clear understanding of the training features and their corresponding labels. So what are you training to predict based on which data? Now let's jump to the next video and see what goes into data pre-processing and feature engineering. See you there!